Hi, welcome to Combination Lesson 8.3 and 8.4, exploring and then applying the cosine law. For the exploring part of the cosine law, we're going to spend a few minutes and develop the law itself, and then applying the cosine law, we'll go over to page 2 of the lesson, and we will see how this works in a couple of quote-quote real-life examples. So suppose we're starting with a non-right triangle, ABC. As you've learned before, the sides are labeled in the lowercase across from the uppercase vertex name. So that would be side A, side C, and then side B across from the uppercase vertex B. Then we take this triangle and then we'll drop a perpendicular from vertex A down to side BC, and we'll call that point D. Now side A here, that length of A, has now been broken up into X and Y. Okay, so if we look at triangle ABD here, since that's a perpendicular we've dropped, that would be a right angle there. So now we have a right triangle, and in triangle ABD we see that we can form or use Pythagorean theorem. So we've got c squared equals x squared plus h squared. But because A has been broken up into x and y, we can say that x is actually this whole length A minus this length y. So x is A minus y. So we'll substitute this into x here to get this next line, which is c squared equals h squared plus a minus y squared. And we know that a minus y squared is not a squared plus y squared, but rather a minus y times a minus y. Then if we perform the distributive property, a times a and a times negative y, and then negative y times a and negative y times negative y, we end up getting a squared and then minus ay, so negative or minus 2ay, and then negative y times negative y gives plus y squared. So then if we look at triangle ADC, the triangle beside that first one, b squared equals h squared plus y squared, and we can now substitute this into, we can substitute h squared into h squared there, and so that is y squared, when we have to rearrange that, this gives us h squared equals b squared minus y squared. Sorry about the hesitation there. And then, so this gets substituted in for the h squared here. So we get a squared plus b squared, which is here, and then minus 2ay. And we've got minus y squared plus y squared, so those two both cancel. Okay, so let me just show this here. So we've got, in this piece, we got c squared equals b squared minus y squared plus a squared minus 2ay plus y squared. So this b squared minus y squared, we're substituting in for h squared here. And then I just rewrote this down here. So c squared equals b squared minus y squared, that was substituted for h squared, plus a squared minus 2ay plus y squared. And the negative y squared plus y squared becomes a zero pair, and they're gone. So we're just left with c squared equals a squared plus b squared minus 2ay. And in triangle ADC, still the second triangle, the cosine of angle C is the adjacent, which is y, over the hypotenuse b. So we've got cosine c equals y over b. And we solve for y, so we multiply both sides by b. So this comes up, so we get y equals b times cos c. And we substitute that in for y here. So then we get c squared equals a squared plus b squared minus 2ab cos c, which is that cosine law there, or that form of the cosine law. Now if we're to do this, we could do this 2 more times, once for a squared and once for b squared. It ends up that the 3 laws would be as shown here. So it's kind of like Pythagorean theorem if you cover up that part. But this is then for a non-right triangle. And notice that the side A, sort of starts the equation and it's ended with angle A. And here same with side B and angle B. And then all these sides just kind of get rotated through the theorem a few times. Now if we were to, so this is looking for a side length. If we're looking for an angle, we just rearrange these. So I don't know, let's take this one and we rearrange that to find B. We want to find an angle. So I'm going to start off with b squared equals a squared plus c squared minus 2ac cos b. And I'm just going to actually turn this whole thing around. And I want to solve for b, or basically solve for cos b, so I'm going to subtract a squared and c squared from both sides. So I'm going to end up having 2ac cos b equals b squared minus a squared minus c squared. And then I'm going to divide both sides by negative 2ac. So cosine of b is b squared minus a squared minus c squared all over negative 2ac. So if we know all the side lengths, like we might in the triangle like this, we substitute their side lengths in for b, a, and c. In this formula we simplify this, take the inverse cosine of both sides to get the measure of angle b. Okay, so let's take a look at how all this works.